Number 15 asks us about the difference between a linear scale factor and an area scale factor. Remember, with scale factors, a linear scale factor is the number I multiply by to go from a line to another line, and the area scale factor is the number I multiply by to go from an area to another area. The link between the two is that if I have the linear scale factor, I can square it to get to the area scale factor. And then, of course, if I want to go backwards, if I had the area scale factor, I could square root to get back to the linear. With this picture, I can see very easily that to go from 15 to 60, the measurements of the lines, that would have to be multiplied by some scale factor, which would be my linear scale factor. In other words, I could think of 15 times some scale factor x is going to give me 60. So if I wanted to figure out what x, my scale factor, is, it's really just a division problem. I divide both sides by 15. 60 divided by 15 gives me my scale factor of 4. In other words, to go from this scale factor, this line to this line, I multiplied everything by 4. So my linear scale factor is 4. If my linear scale factor is 4, I have to then square to go to my area scale factor. 4 squared is 16, so that means that my area scale factor is 16. So whatever number was the area of this weird little shape was multiplied by 16, because I'm talking area, to get this big area. So then to go backwards, I do the opposite of multiply by 16. I would divide by 16 to get my small area. So the area of the big shape, 480, divided by that scale factor of 16, because I'm going backwards to the small one, gives me the area of the small shape, which was 30. In other words, 30 times my scale factor of 16 gets me to 480. So the area of the small shape must be 30 millimeters squared. All right, next one. These 4 problems are all just formula problems. You'll be given the formula for all of these questions on your test, so this should be pretty easy. The most important thing is to read the instructions and realize that we have an 18-sided polygon, so that means that n equals 18 for all of these formulas. For A, the first formula asks us the sum of the interior angles of a polygon. That formula is 180 times n minus 2. Well, since n is 18, I'm going to do 180 times 18 minus 2, or in other words, 180 times 16. When I solve that, when I compute that, I get my answer of, for part A, 2,880. Then to go to part B, I know that my formula is 180 times n minus 2 divided by n. So this part we already did for part A, and we knew that that was 2,880. So if I divide that by n, which is 18, I'll get what part B is, which is 160 degrees. Part C asks us the sum of the exterior angles of the polygon, and every single polygon we meet always will have a sum of exterior angles of 360 degrees. And a quick explanation of that is the exterior angles are the angles that are formed if you were to extend all of the side lengths of this polygon, something similar to this. These exterior angles all add together to give us 360, because you can start to see the circular shape going around the outside, and we of course know that a circle has 360 degrees. Next, what is the measure of one exterior angle? Well, if all of these red angles added together is 360, and I'm going to have 18 of them for this picture, this formula is just 360 divided by how many angles you'll have, or how many sides you have in that shape. So in this case, 360 divided by 18 sides will get me 20 degrees for each of the angles. Next up, here I have a small shape, and it is going to be enlarged to get a new bigger shape that has a big, huge area. So if I were to think about the bigger shape, I'm not going to try to draw it very accurately. Let's pretend this shape is much bigger. Okay, that's the bigger one. The area of this new bigger one is 1,920 inches squared. So So that means we could very easily find our area scale factor, similar to what we did in number 15. The area scale factor is going to be basically 1,920 divided by 120. 1,920 divided by 120 gets me my area scale factor of 16. Be careful, this is the area scale factor. So if we go back and we take a look at our drawing that we did on number 15, I'm right now at the area scale factor. So to go backwards to the linear scale factor, we have to square root. So my linear scale factor would be the square root of 16 in this case. My linear scale factor is going to be square root of 16, which is 4. This is important because our job here is to find the perimeter of the new enlarged shape. Well, since I'm finding perimeter, doesn't perimeter have to do with lines and not area? So between the two options, my two scale factors, I either have an area scale factor or a linear scale factor. Perimeter is all about lines, so I'm going to use the linear scale factor. The small perimeter times the linear scale factor is going to get me the big perimeter. So the small perimeter is 5 plus 7 plus 2 plus 3 plus 3 plus 10. My small perimeter is 30 times my linear scale factor of 4 is going to give me my big perimeter of 120 inches. It just was a coincidence that it was the same as the original area. Don't think that's going to happen every time. Okay, so my new big perimeter is 120 inches. All right. Next, we have another scale factor question. The shape below has an area of 15. We're going to enlarge it with a scale factor of 4. Ooh, we're really sticking with 4 today. Okay, our linear scale factor equals 4. So what's my area scale factor? Well, 4 squared, which is 16. So to go from an area to a new area, I better use the area scale factor. In other words, 15 times 16 will get me my new area of 240. So 240, what are we in? Meters squared. All right. On this page, we're talking about Mary and her photo. This is a similar question to a quiz we had earlier. Remember that when we talk about cost is dependent on how big the photo's area is. So when you think about cost, I want you to think of area, okay? We have our original small photo and its cost, or I'm going to put it inside because it has to do with area again. Our small area is, or our small cost is 0.44. We're going to enlarge it by a linear scale factor of 3. Linear scale factor equals 3. So what would my area scale factor be? Well, that would be 3 squared or 9. So if I want to find the new bigger cost, again, cost has to do with how big the area is. So I'm going to take this 0.44 and times it by the area scale factor of 9 to get my big cost. 0.44 times by 9 gets me my new cost, which is $3.96. We have a similar question down here, but it's basically backwards. It says Mary's mom already enlarged the photo and it cost her $11. And we want to know what dimensions, or like how much bigger, or what are these new dimensions for the bigger size photo. Well, we could find the area scale factor pretty easily by saying, okay, well, our original one cost 44 cents from the problem above. So our original one cost 44 cents. What must have the area scale factor been? Of course, we'll figure that out by doing 11 divided by 0.44. 11 divided by 0.44 gives us an area scale factor of 25. So that means that this guy's small cost was times by an area scale factor of 25 to get to this big cost. So then if my area scale factor is 25, I have to go backwards or square root to get the linear scale factor of the square root of 25 is 5. So that means this photo is 5 times, like the lines are 5 times as big over here. So to go from this line to this line, I need to use the linear scale factor of 5. So 5 times 5 gets me 25 here. And of course, I'm doing another line here. 4 times 5 gets me 20 for that side. Finally, we need to use special right triangles to find the area of this hexagon, regular hexagon. The first thing I'm going to remember is that the area is equal to the apothem times the perimeter divided by 2. We have neither the apothem or the perimeter right now with our given picture, so we're going to have to do some work. The first thing I'm going to do is draw our apothem in here, which remember always goes from the center of the circle to a 90-degree angle with one of the sides of the shape. And let's see, I'm next going to find this angle measure here. I know that the measure of one interior angle of a regular polygon can be found by doing the formula 180 times n minus 2 divided by n. In this case, since I have a hexagon, n is 6. So I'm going to do 180 times 6 minus 2 divided by 6, or 180 times 4 divided by 6. When I compute that, I find that one of the angles is 120 degrees. So each of these angles around the circle is 120 degrees. Now, focusing on just the triangle here, I'm going to take this triangle out so we can play with it a little bit more. I've got this situation going on. He's upside down right triangle. We've got our apothem here. That's what we're trying to find. And we know that the angle is really coming from half of this 120 degree. Remember, we're not using the whole thing. So this angle must be 60 then, because half of 120 is 60 degrees. Well, if that's 60 degrees, then this must be 30, and oh my goodness, we have a special right triangle. The formula for special right triangles goes like this. The number across from the 30 degrees is always x. The number across from the 60 degrees is x root 3. And the number across from the 90 degrees is 2x. We know from our original picture, I guess I should have drawn this in, that this line, the radius, or in case the hypotenuse of this right triangle, is 12. Sorry, I forgot that in my picture. So that means, looking at our special right triangles map, we are right now at the hypotenuse, which is represented by 2x. To move back to this line, we just need to take 2x to x, so that means divide by 2. So if I were to do that over here, 12 divided by 2 will get me the length of this line. So that means that line must be 6. Then, once I am at x, I can go to this side by multiplying by root 3. So that means over here, 6 to this side must be multiply by root 3. That means our apothem must be 6 root 3. Okay, let's take that idea back to our formula. I know the apothem is 6 root 3. Now, what about the perimeter? We found this line is 6, which remember in our original picture is right here, this little yellow bit. This yellow bit does not represent the entire length of this side of the hexagon. It, in fact, only represents half. So if this piece is 6, the entire length must be 12. And then if I want the perimeter and all of these sides are equal, well, I have 6 of those sides that are each 12 inches long. So I need to do 12 times 6, or 72. My perimeter must be 72. Now we are ready to compute the area. The area is going to be the apothem, which is 6 root 3, times the perimeter, which is 72, divided by 2. To simplify this problem, we can go ahead and multiply. Remember to multiply only like terms. 6 and 72 are plain old numbers, so we can multiply those together to get 432 root 3 on the top. We still haven't divided by 2 yet, but we are allowed to as long as we keep within like numbers. 432 divided by 2 gives me a number of 216. Remember to keep that square root 3 with your answer, and we have found the area of this shape. Since I don't have any inches, centimeters, meters, I'm just going to use the letter U for units. The area of this regular hexagon is 216 root 3 units squared.